Okay, here's a question about a circle. We've got an equation in that form. First thing we've got to do is completing the square to get it into this form. Now you'll have examples of this in your booklet for chapter 4. What I'd strongly recommend is you separate out the x squared plus 2x and complete the square on that. Do the same with the y's. Don't forget the 12s. Do the different pieces separately, put them back into that form, and then rearrange into this. Once you've got it in that form, the coordinates of C and the radius of the circle you should be able to read off from this standard equation. The thing to be careful about is, have you got an r or an r squared there? And the radius, of course, is r, not r squared. Again, you've got examples like that in chapter 4. We've got to show the circle does not intersect the x-axis. Now, intersecting the x-axis is when y equals a particular value. So you put that particular value into your equation for y. You could put it into either of those, and that will give you an equation that you're not going to solve because you want it not to intersect the x-axis. So therefore, you want your equation to have no solutions. And you need to remember from the first chapter the recipe for how you tell whether a quadratic equation has 1, 2 or no solutions. You have to quote a particular formula beginning with b squared, decide what a, b and c are for your equation, substitute in, get a value and interpret it in such a way that hopefully you'll be able to say, oh, this equation has no solutions, so therefore the circle does not intersect the x-axis, and make sure that you finish by drawing the conclusion the circle does not intersect the x-axis. State that clearly. Then in part D, we've got the line with equation x plus y equals 4 intersecting the circle we've been dealing with earlier. Intersection means the method is for points of intersection, which is simultaneous equations. Here's one equation. The other equation is at the top of the page. If you successfully did part A, you could use this one, or you could use the original equation, which you know is correct, but either should work. In order to do that, you need to make x or y the subject of this equation, but to decide which, you have to look at where you're heading. Dot E1 is a show that question, which means that this is our end point, and you'll see that the equation we're aiming for has got x's in. So that means that rather than making x the subject of this in terms of y and getting an equation out full of y's, I need to make y the subject of this equation, so that when I substitute in with lots of x's in to one of these, I'll get out an equation with x's, which should reduce to that as your end point. But put this on one side to begin with. It's not obvious when you start how that equation is going to develop. You start with the simultaneous equations that you want to solve. Okay, here's a re-entry point. We're still talking about these same points P and Q that we're dealing with here, and this equation applies to P and Q, so you need to solve it. Now this could confuse you. You've been given the coordinates of P. They didn't need to do that. In fact, that means that you already know one of the x values you're expecting to get when you solve this equation. And for the coordinates of Q, you're going to use the other x value and a corresponding y value, which you can get from either of the equations, but probably that one, that you solve simultaneously. And then, hence, using what you've just done, so we've got the coordinates of Q, we want the midpoint of PQ, so you need to remember your midpoint method for 2 points from chapter 3 to combine the coordinates of P with the coordinates of Q to get the midpoint.